The formula that we are using for differentiation is when y is x to the power of n, then dy by dx is n x to the power of n minus 1. See how the power goes in front of x and then it decreases by 1. So, for example, if we have y equals x cubed, which we have in our question, then dy by dx will be 3 times x to the power of 3 minus 1, so it's 3x squared. Whereas if we have y equals x, remember that x is the same as x to the power of 1. So when using my formula, we have dy by dx in this case equals 1 x to the power of 1 minus 1. So it's 1 times x to the power of 0. Remember that x to the power of 0 is 1, so we get 1. Now going back to our question, in our case, dy by dx is going to be 4 times the derivative of x cubed, 3x squared, minus 2 times the derivative of x, which is 1, plus the derivative of 5, which is 0. So we get 12x squared minus 2. This is our answer. Moving to question 2. Find the coordinates of the point on the curve where the gradient of the curve is 1. We have here an equation. The word is tells me that I need to form an equation. Gradient of the curve is dy by dx is 1. So here is my equation. Let me write it again. Dy by dx equals 1. Now from the first question, dy by dx, remember, is 12x squared minus 2 equals 1. And we have a quadratic equation, but it's a special form of it, so we can write it as 12x squared equals 3 if we add 2 on both sides. Then if we divide by 12, we get x squared equals 3 over 12, or x squared equals 1 over 4. So x is 1 over 2, or negative 1 over 2. If we struggle seeing this, we could look at this form, here. Take 1 away from both sides and just solve it using the quadratic formula. So going back, x is either 1 over 2 or negative 1 over 2. I'm asked about the coordinates, so I need y now. If x equals 1 over 2, y is 4 times 1 over 2 cubed minus 2 times 1 over 2 plus 5. Replace this in your calculator and put here the answer, same for this point.